Lesson 8.5 is on solving quadratic equations by graphing. So in this lesson, we'll solve quadratic equations by graphing them. In previous lessons, we learned about how to identify some important things like the line of reflection, the y-intercept, the vertex, and those are going to be important here to help us graph these quadratic equations. So every quadratic function has a related quadratic equation. A quadratic equation is an equation that can be written in standard form, ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a doesn't equal 0 because otherwise you wouldn't have that x squared term, therefore there wouldn't be a quadratic. So when writing a quadratic function as its related quadratic equation, you replace y with 0. Okay? So it'll look like this. Or it could be flipped the other way where you have the ax squared plus bx plus c equals 0. Now, one way to solve a quadratic equation in standard form is to graph the related function and find the x values where y is 0. In other words, find the zeros of the related function. And recall that a quadratic function may have 2, 1, or no zeros. And that's where it's going to cross the y-axis. So step 1, we'll write the related function, so replace y with 0, so set it equal to 0. Graph the function, and then find the zeros. So look for where it crosses the y-axis. So we're going to start by looking at example 1. A, we have 2x squared minus 2 equals 0. So it's already in this standard form where it's 0. You could also rewrite it as 0 equals 2x squared minus 2. Okay. So here, a couple things that we're going to want to do is to find the axis of symmetry. So x equals negative b over 2a. So a here is 2 and b equals 0. So I'll have negative 0 over 2 times 2, and this is going to give us 0. So the axis of symmetry is 0. So right here, our y-axis will be our axis of symmetry. And then to go find our vertex, we're just going to substitute in 0 for x. So y equals 2 times 0 squared minus 2. And that's going to give us negative 2. So our vertex is 0, negative 2. So 0 down to right here. Okay? And then our y-intercept is actually the same thing because that's where it crosses the y-axis. So now it's helpful to get two other points. So you can substitute in 1 and 2 into this equation. So if x equals 1, we're going to have 2 times 1 squared minus 2, which will give us 0. So another point would be 1, 0. So write 1. And then if I put in x equals 2, so 2 times 2 squared minus 2. 2 squared is 4, times 2 is 8, minus 2 gives us 6. So another point would be 2, 6. So write 2 up, 1, 2, 3, 4, 5, 6. Then we could reflect these points over. So this guy's 1 over, so I'm going to go 1 to the left. This is 2 over, so 2 to the left. And then I can connect my dots to form my parabola. So this is what my graph would look like. And then here, we just have to state what the solutions are. It crosses right here at negative 1 and 1. So the zeros are negative 1 and 1. Okay, so that would be how we would solve it. So now we're going to go ahead and look at B. So we have negative x squared minus 4x minus 4 equals 0. So we're going to go through that same process. We're going to go ahead and find the axis of symmetry, the vertex, y-intercept, and two other points, reflect them, and then look for our zeros. So starting with the axis of symmetry, A here is negative 1, and B is negative 4. So x equals negative b, so negative 4 over 2 times negative 1. So that is going to give us a negative 2. So the axis of symmetry is at negative 2, which is right here. Then I'm going to go find the corresponding y to get my vertex. So we're going to have negative 2 squared minus 4 times negative 2 minus 4. And when you find that, you are going to get 0. So our vertex is negative 2, 0. So negative 2, 0 is right here. And then I'm going to go ahead and find my y-intercept. My y-intercept is when x is 0. So when I put in 0 for x squared and 0 for x here, that's going to give me 0, and I'm left with negative 4. So 0, negative 4 is going to be my intercept. So right here. And then I can go ahead and get another point. Since I already have 2 here, let's go ahead and do x equals negative 1. So I'm going to replace x squared with negative 1. So negative 1 squared minus 4 times negative 1 minus 4. And that is going to give me negative 1. So another point is negative 1, negative 1. So right here. So now I'm going to go reflect those. So this guy is 1 from the axis of symmetry. So I'm going to go right here. This guy's 2 over, so 1, 2. And then I'm going to go ahead and connect my dots to form my parabola. So here, there's only one point that crosses on that x-axis, so we're only going to have 1, 0. So the 0 here is negative 2. So we only have one solution. So remember, you can have 2, you can have one solution, and you can also have no solution. So now we're going to go ahead and look at C. For C, I have x squared plus 5 equals 4x. So I need to rewrite this one in standard form first. So I'm going to subtract 4x from both sides. So x squared minus 4x plus 5 equals 0. So here, my A is 1, B is negative 4. So to get my my axis of symmetry, I'm going to have x equals negative, and then b is negative 4 over 2 times 1. And that is going to give me 2. Okay. So then I'm going to go find the corresponding y value. So I'm going to have y equals 2 squared minus 4 times 2 plus 5. And here, 2 squared is 4, and then 4 times 2 is 8. So 4 minus 8 and plus 5, that gives me 1. So my vertex is 2, 1. So my axis of symmetry is 2. So right here. And then my vertex is 2, 1, which is right here. And then to do my y-intercept, this is when x is 0. So if x is 0, these guys will disappear, and I'm left with 5. So 0, 5 is my y-intercept. So 1, 2, 3, 4, 5. And I'm going to get one other point, so let's see what x equals 1 gets us. So we're going to have 1 squared minus 4 times 1 plus 5. 1 squared is 1. And then 4 times 1 is 4, so 1 minus 4 plus 5, and that gives us 2. So another ordered pair would be 1, 2. So right 1, up 2. And then I can reflect this point over here and this one over here. So this is 1 away, 2 away. And then I can go ahead and connect them to form my parabola, and it'll look something like that. Now, this parabola does not cross the x-axis at all. So here, this equation has no real solutions. So again, this parabola does not cross the x-axis at all. Okay, the vertex is right here, which is above the x-axis. So since this parabola doesn't cross the x-axis, this equation has no real solutions. So example A, we looked where there's 2. Example B, 1 solution. And then C, no real solutions. So now there are 3 for you to do. So 3 check it out problems. So you're going to take a moment, pause the video, and then resume when you're ready to check your answers. If you want to resume to check A, pause again, check B, pause again to check C, that is fine as well. So take a moment to do these 3. So for A, we're going to rewrite this guy first. We're going to subtract 2x squared from both sides. So x squared minus 2x squared will give us negative x squared. And then I have minus 8x minus 16 equals 0. Now, you need to identify the axis of symmetry, which is going to be negative 4. So x equals negative 4. And then our vertex is going to be negative 4, 0. So negative 4 is right here. And then negative 4, 0 is right here. Then from there, your y-intercept. So x is 0, so y is going to be negative 16. So that doesn't really fit on our graph here, because I'm counting by 1, so I'm just going to leave that one out. And then if we do another point, I could do, if x is, say, negative 1, if I substitute negative 1 in there, we get negative 9. So negative 1, negative 9. So here, I can reflect that over and then connect these to form a parabola. And now you'll see that it just crosses the x-axis at one point. So here, the 0 is negative 4. Now you can get some more points. You can do negative 2 and negative 3 if you want, but this is just approximation for now to show that there's only one 0 in this case. For B, I'm going to have to rewrite this, so I'm going to add x squared for both sides. So I'm going to have x squared plus 6x plus 10 equals 0. So for this one, my axis of symmetry is net negative 3, and my vertex is going to be negative 3, 1. So negative 3 is right here, so that's my axis of symmetry. And then negative 3, 1 is right here. Y-intercept is when x is 0, so we would be left with 10. So 0, 10 is right here on my graph. And then to get another point, you could do negative 1. So when x is negative 1, y is going to be 5. So negative 1, 5 is right here. So then I can reflect these. This guy's 3 over. So our graph will look something like this. So in this case, it doesn't cross the x-axis at all, so there are no zeros. C, I have negative x squared plus 4 equals 0. This is in standard form. So here, my axis of symmetry is going to be 0, and my vertex will be 0, 4. So axis of symmetry is when x is 0, so that's our y-intercept, so this guy right here. And then 0, 4 is my vertex. And then to get my y-intercept, I'm going to substitute in 0 for x, which this guy is my intercept. So I'm going to get 2 more points. So I'm going to say when x is 1, y is going to be 2. So right 1, up 2. And then another coordinate, if you substitute in 2, you get 0. So right 2 and then 0. Reflect these over, 1 over, and then this guy's 2 over. Our parabola will look, sorry, that was very terrible drawing on my part, will look something like this. So here, zeros are negative 2 and positive 2. So now we're going to go ahead and look at example 2. So in example 2, it says a dolphin jumps out of the water. The quadratic function y equals negative 16x squared plus 20x models the dolphin's height above the water after x seconds. How long is the dolphin out of the water? So when the dolphin leaves the water, its height is at 0. So when the dolphin re-enters the water, it's also at 0. So we're going to solve this equation to find the times when the dolphin leaves and re-enters. So here we're going to go ahead and graph it. So the zeros after you graph it are going to be 0 and 1.2 or 1.25. So 0 is where it's starting, where it's leaving, and then 1.25 is when it's re-entering the water after jumping. So the dolphin is out of the water for 1.25 seconds. Okay. And you can use a graphing calculator for this. You can use Desmos.com, or you can graph it by hand. So now the check it out problem. It says another dolphin jumps out of the water. The quadratic function is y equals negative 16x squared plus 32x. Models the dolphin's height above the water after x seconds. How long is the dolphin out of the water? So we are going to start by finding the axis of symmetry, the vertex, y-intercept, another point. Reflect that if we need to help us figure out how long it is in the air. So we have A is negative 16, B is 32. So x equals negative, and then b is 32, over 2 times negative 16. And this is going to give us a positive 1. So the line of symmetry is at 1, so right here. Then to go find the corresponding y value, we are going to substitute that in. So y equals, we'll have negative 16 times 1 squared plus 32 times 1. And that is going to give us 16. So the vertex is 1, 16. So 1 and then up 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So right here. Okay, and then our y-intercept, when x is 0, that becomes 0. That also becomes 0. So our y-intercept is the origin, so 0, 0. So right down here. Then I'm going to go ahead and pick another value for x. So let's say 2, okay, because we did 0, so this is where it's starting. It's going up, and then let's try 2. So if I substitute x equals 2 in, I'm going to get y equals negative 16, 2 squared plus 32 times 2. So here, when I do this, 2 squared is 4, and then negative 16 times 4 gives us negative 64. 32 times 4 is 64, so this gives us 0. So this ordered pair is going to be 2, 0. So right here.
724, 724, 724 is loading at this time.
If you connect your graph, it'll look something like this. So this is where the dolphin is starting, and this is where it's ending. So it's going up and down. So that whole time, it's taking 2 seconds. So the dolphin is out of the water for 2 seconds. So it's starting at 0, 0, going up, down at 2, 0. So that takes a total of 2